welcome everyone. Today is lecture 6 of probability and statistics. Today we will learn about correlation coefficient and linear regression. Correlation coefficient. Correlation coefficient is a quantitative measure of relationship between variables. It tells us about how change in one variable affects change in another variable. It is of two types, positive correlation and negative correlation. Positive correlation means if, let's say, x is increasing, then y is also increasing, or both of them are decreasing. In negative correlation is if one of the variable is increasing, then another is decreasing, or vice versa. Our next term is Pearson's correlation coefficient. It is denoted by P of xy and it equals to sigma xy upon sigma x sigma y, where sigma xy is covariance of x and y and sigma x is standard deviation of x, sigma y is standard deviation of y, where sigma xy equals to 1 by n summation xi minus mu x into yi minus mu y. We can also write it as expectation of xy minus expectation of x multiplied with expectation of y. Our next term is sigma x, which is 1 by n times summation of xi minus mu x square. Our next term is sigma y square, which is 1 by n times summation xi minus mu y whole square. We can also write it as expectation of x square minus expectation of x square. We can also write this as expectation of y square minus expectation y square. Now we will learn about scatter plots and how we can get that if R is positive or not. Let's say we plot a graph where this is x-axis, this is y-axis, and we have R as a line. Then if this theta is less than 90, then our R is positive and these two variables are positively correlated. If this is x, this is y, and this line which denotes R, theta greater than 90, then our R equals to negative. And if R is a line parallel to x-axis, then these two variables are uncorrelated. Now we will discuss properties of Pearson's coefficient, which is denoted by R or Pxy. This is also called as product moment correlation coefficient. It only tells us about linear relationship between x and y. R lies between -1 to 1 close bracket That means it can also take values -1 and 1. If r equals to -1, then x and y are perfectly negatively correlated. That means x equals to -y. If r equals to 1, then x and y are perfectly positively correlated. That means x equals to y. And our Karl-Pearson's coefficient is independent of change in origin and scale. That means r of ax plus b, comma cy plus d equals to ac upon absolute value of ac r x comma y. We can also write this as rax plus b cy plus d equals to rx plus y if ac greater than 0 and minus rx comma y if ac less than 0. It just depends on the sign of ac. Note their value. And if we have r equal to 0, that means both the variables are independent. But if we have independent variable, that means r equals to 0. But if r equals to 0, it doesn't mean that our variables are independent. Our question is, we have to calculate Karl-Pearson's coefficient. Our n equals to 50, summation x equals to 75, summation y is 80, summation x square is 130, summation y square is 140, and summation xy equals to 128. We have to find px comma y, which equals to summation sigma xy upon sigma x sigma y. Sigma xy equals to e of xy minus ex ey. Sigma x equals to under root e of x square minus ex square. Sigma y equals to under root e of y square minus e of y square. Now we have to find values exy, ex, ey, ex square and ey square. Exy equals to 1 by n times summation xy. So this will be equal to 1 by n. This will be equal to, putting the value of n, 1 by 50 into 128. E of x equals to 1 by n times sigma x. This equals to 75 by 50. E of y equals to 1 by n times sigma y. This equals to 80 by 50. Our e of x square will be equal to 1 by n sigma x square. This equals to 1 by 30 by 50. Similarly, e of y square equals to 140 by 50. Now we have to calculate these three values. So sigma xy will be equal to 1 by 28 by 50, 128 by 50 minus ex 75 by 50 multiplied with EY 80 by 50. Sigma x equals to under root of E of x square 130 by 50 minus EX square 75 square by 50 square. Sigma y equals to E of y square, that is 140 by 50 minus 80 square by 50 square. Now we will just put these values in this formula. So our P of xy will be equal to sigma xy's value, that is 128 into 70 into 50 minus 75 into 80 by 50 into 50 by taking the LCM by sigma x. This will be equal to 130 into 50 minus 75 into 75 upon 50 into 50 into 140 into 50 minus 80 into 80 divided by 50 into 50. If we will solve this, then we will get P of xy equals to 0.55, and that is our answer. That's all. In our next lecture, we will continue to our topic correlation and linear regression. Thank you.